So I want to talk about some of the simplest visualization commands in Mathematica. So probably the most straightforward one is simply called plot. So we do plot and then we give our function and we give the range of this variable. So here we're plotting x squared, where x goes from 0 to 2. And there we have it. Shift return evaluates the command and we see our curve. So one of the things you can do with plots is you can compare multiple different curves. So rather than plotting just one curve here, we can replace this with a list of different curves. For example, maybe we want to plot x squared, x, and x cubed, say. And there we have it. So Mathematica generally plots the first curve in blue and then the second one in purple and the third one in yellow, but you can easily change the colours it uses for different curves. In fact, you can change many aspects of a plot. Essentially, after you've specified the plot range, which here is from 0 to 2, you can put lots and lots of extra commands on the end to sort of enhance the plot and add extra details. So a simple example is maybe you want to add some axis labels. So you put axis labels and then an arrow, and then you use speech marks so that you're making strings, and the first string is the name that you want to give the x coordinates, and the second part is what you want to call the y coordinate. There we go. Yes. So there's just so many options. Of course, this looks quite small, but you can change the size of the text and so forth. Also, note that you can just use your mouse to resize the plot manually. Okay, so often when you do plots like this, it's good to have a kind of reminder of what the functions actually represent. So we can use a different command here. I mean, there's just so many of these so-called options that you can put on the end. So, for example, if we put plot legends, and there are various different things you can put here, as you can find it in the help command, but if you just put expressions in here, then you get this nice little legend which just shows you quickly what these different curves are. Another fairly useful thing you can do is to do filling. So say you just have a couple of curves, curves 1 and curves 2, so then if you say filling, oops, better delete that bit. One goes to 2, then you get this nice little shaded plot showing you the sort of area between these two curves. And this is fairly useful, for example, if you want to visualize some kind of thing in calculus, or just, the differences between the integrals of two different curves. Now, another thing that is fairly useful, if you just have a couple of curves like this and you want to get a very fast idea of something, is to use a command called get coordinates. So to do this, you just right click on your plot and then get coordinates. So say you wanted to find out where these two curves intersect. Well, just hang your mouse over that point and you see it's about 0.11. Okay, so the commands underneath this plotting thing are very clever, and they generally figure out a good way of laying out information even if you don't specify everything. So if we give Mathematica a bit of a challenge, like plotting this function here, 1 over sine 1 over x, let's take x from 0 to 2 pi. And so this is a really nasty function. It goes to infinity a lot, but Mathematica plots it in a fairly easy to see way. But you might want to change the range on this, so you can do that fairly easily. So now we're just seeing the values where the y-axis goes from 0 to 5. So we can change this plot range, of course, and Mathematica usually does a fairly good job of showing the curve. Now, another thing that you might want to do is to make the colour of the curve a bit more interesting. So one thing you can do here you can use this thing called ColorFunction. So ColorFunction essentially tells Mathematica how to change the colour of the curve according to its coordinates. Now, you don't have to put in anything too informative. You could just use one of the built-in functions, for example, the rainbow function. And then you get this nice colourful curve like this. But maybe you want to be a bit more explicit about how you actually want the colour of the function to change. So, in general, you can just make it a function which has two inputs, which we'll call x and y, because they refer to the x and y coordinates of the points. And then you can just say, you just have to write a colour which depends on those things. So we could just say that we'll have it as the hue function of y. So this hue function changes red, yellow, green, blue, purple as the y coordinate increases here. Okay then, so one of the most useful plot options is something called plot style. So if we just plot the curves x and x squared, then we get something like this, where the styles of these curves have already been set by default. But we can change the plot style, so rather than having a purple curve and a blue curve, we can change things. So maybe we want to have a green curve and a yellow curve. There we are. But we have many more options than just that. So, for example, maybe we want this green curve to be dashed. And it's really as easy as that. And so there are many things you can do. Maybe we want to make this yellow curve a bit thicker. And there we have it. And one can add in the color functions and all kinds of things into this kind of command. It's really very useful. Okay, so there's so many options for things like this plot command that it's fairly useful to be able to pick up commands as you go and learn about things quickly. So if you have Mathematica 9 or something better, then the plot command comes in with this kind of built-in thing here where Mathematica tries to guess what kinds of extra commands you might be interested in. So just by clicking around with this, you can easily change a lot of things to do with your plot. So if you just click plot style, then you're taken into this kind of interactive interface where you can quickly change things about this plot. So we could make it purple with a dot dashed line. And then if we just click done, not only does it apply those changes, it also shows us the command which it used. So this is a great way to do things fast and to get a really kind of good list of commands which you can then manipulate. Now another thing you can do is to change the image size. So maybe you want it very tiny, and there we have it. Now in this case Mathematica's used this percentage command. So this percentage command basically refers to the one of the previous results which has been outputted. So for example, we could say 3 plus 4. And then the next time we use percentage, it just takes the last output and redoes it. So this is in general a fairly unstable way of programming, but it's very useful when you're just doing things quickly and trying to get a very fast idea of an answer to something. Okay, so another fairly useful thing to be able to do with this plot command is to use it in conjunction with another command called manipulate. So manipulate is an extremely useful command which basically allows you to make things dynamic. So let's say we want to learn about what this function is like, x plus x squared plus a times x cubed. So we'll take x from maybe minus 2 to 2. So that's what we want to plot, but of course it's not specified properly because we've left this parameter here unnamed. So we'll change this parameter from, say, minus 2 to 2, and let's evaluate this. So now what we've got is a sort of dynamic thing where we can just use this slide bar here to change the value of a, and we can see how our curve changes form. So this is a really wonderful way to understand things in mathematics a lot easier, and it's very useful to visualize large parameter spaces because often you'll have a curve which depends on 6 or 7 different parameters, and of course it's very difficult to visualize a 6 or 7 dimensional plot, but with manipulate it's fairly easy to get an idea of what's going on. Now I'll talk more about manipulate in a later video, but the basic idea is kind of like this. You can have multiple variables as well, so we could put a b in here, and maybe we'll also have b going from minus 2 to 2. And now we can just change these variables individually. We can also make Mathematica vary them as we watch. So there's all kinds of chances to have fun here. Okay, so for most of these continuous plotting functions like plot, there's a sort of discrete analog which can be used to visualize data sets. So let's just make a data set quickly. How about we just do array prime hash, and we'll go all the way up to 20. So this gives us the first 20 prime numbers. Now let's use this as our data set. So we'll give it a name. We'll call it data 1 perhaps. And then it's very easy to visualize it. So if we just put ListPlot, and there we have it. So basically, you can have many different kinds of inputs for ListPlots. So obviously the simplest is just a list. And so we have the first prime in our list, the first element in our list here, and the second one here, and so forth. We might also want to actually specify both coordinates. So we could do ListPlots, and we could have rather than having a list like this, which is sort of like what we had last time, we might want to specify both coordinates. So maybe we want to have this first point at x coordinate -1, y coordinate 1, and the second one with x coordinate 3, y coordinate 7, and the third point with x coordinate 0, y coordinate 0. So here we are. And you can also join up these points, that's one of your options. So just put joined goes to true. You join them by a line. And so this joins the points up in sequence. So in this case, these lines aren't always going up to the right because the x-axis is skipping. The x-axis, x-coordinates of these points are skipping, not always increasing, but sometimes going backwards. Okay, so the way that ListPlot is structured is very similar to the way that plot is structured. So for example, we change the plot range or the plot style in just the same way. Also, we can change the filling. So if we just, there we go, want to do a list plot of our data, we see this. But we can change this filling and fill down to the axis, and then we just get these little lines showing us more explicitly how high these different points are. And we can also plot multiple lists on the same plot in a fairly straightforward way. So maybe data 1 ought to be our first list, and our second list, perhaps it's a table of the coordinates of a coordinate I and coordinate 3 times I, where I goes from, let's say, 2 to 20. I'll turn off this filling command. And so there we have it. And we can do all the general kind of things like join goes to true. We can put axis labels on here. And so forth. Okay then, so we can also change lots of things about the plots by using the old plot style command again. So this is our basic plot of this data. But we can change the plot style. Perhaps we want to make these points green. And we could change the point size. Point size, not dies. Plot size to large. There we go. And this kind of thing is fairly useful for making things which print nicely and are easy to see. And one can do all the usual things, changing the color and so forth. Okay, so we have these two different plotting functions, you know, the standard plot and the list plot. And a great thing we can do is combine them together. So we have this this plot here, which is showing us the first few primes, and we could also make a plot. Let's say we're trying to guess what this curve is. So maybe we have a go with the curve 3 times x, where x goes from 0 to, say, 17. Okay, so we have these two different plots, one of which is continuous, one is deriving from some data, and now let's say we want to compare them. So one of the most useful commands in Mathematica is this command called show. And basically what this does is it displays multiple pieces of graphics over the top of each other. So there we have it. Okay, so when you're doing these two different plots, one has to be a little bit careful to make sure that the options of both plots are consistent. So, for example, if you put axis label on this continuous plot of the straight line and you evaluate it, notice that it hasn't actually shown us these labels of the axes, A and B. So in this case, we have to put the axis labels on both plots, and then they appear. Okay then, so we've had a look at a few different commands. So let's now take a look at how to kind of combine them together. So as you see here, I've had a go at trying to fit this data. So here's the old data set I was looking at, data 1. Okay, so let's make that a bit richer. We'll make a table of I and data 1 I, where I goes from 1 to the length of data 1. Okay, so basically all we've done is added some x coordinates explicitly. Let's call this new list data 2. Okay, so let's say we actually want to plot a straight line to this data set as accurately as possible. So we can do that using a command called fit. So if we simply put fit and then the name of our data set and the kind of function which we want to plot, which we want to fit to it. So we want to fit a straight line. So we'll name this function in terms of x, but we could easily use any other name. So we want to have it as a function of 1 and x, and the variable is x. Okay, so this is the straight line which best fits that data. So now we can do a plot where we can show okay, so we want to do a list plot of data 2, and we also want to do a plot of this curve. And what do we want x to go from and to? Well, I think we want it to go from, yes, 1 to 20. So x should go from 1 to 20. So that's our plot, and we close that, and here we have it. You see it gives a fairly good plot here. And just to show you about this fit command a bit more, if we want to get a little bit more accurate, maybe we want to include a squared term in here as well. So we could easily put an x squared term on the end, and then we get this more kind of more sophisticated function which we're using. So now we've got a little bit of curvature. We can fit the points a bit better. So fit is a very kind of flexible function which you can use to do a lot with. And then there's also another command in Mathematica called find fit, which is it's actually even more kind of useful in a way. So again, let's take a table of the primes. So we'll take the first 20 primes. Here we are. And suppose we want to find a curve fit to that. Well, I think we can get more accurate by, so basically in general with find fit, you specify a data set and then you specify a curve type and then you tell it what are the fitting parameters and what kind of variable do you want to have. So we can do find fit of this. Here's our data sets. And then maybe we want to have a curve like this. We want to have log of BB plus CC times, let's use V instead of X, just for a change, times AA times V. So that's our function. And our curve fitting parameters are called AA, BB, and CC. And the actual plotting variable is just called V. So from this we find out that these are the best values of AA, BB, and CC to fit this data. Now, when I first saw this, I was a little perturbed because I didn't know how to actually get these numbers out explicitly. But it turns out there's a fairly easy way to do it. So if we want to get our function, whoops, here it is, and we can use a command called replace all. So then we put our function in, and what it's given us here as an output is actually some replacement rules. So if we just put our replacement rules in here, then it simply replaces the wherever it sees AA, it writes 1.4207, etc. And so we get this as our function. Just as a matter of interest, it's a lot faster to use this shorthand here, which is /dot. It basically does the same thing as replace all, but it's a lot faster to type. It gives you the same thing. Well, anyway, let's just see if this curve here, which we've got, is a better fit than what we were looking at previously. So here's the plot. I want to show these two together. And there we have it. Looks like that's a much better fit. And you see that the find fit function is it's kind of more general than the fit function because you can put, well, it's a lot easier to use because you can put in the type of expression you want in a very general sort of way. And Mathematica will naturally figure out, or at least have a go at figuring out what's the best function to fit your data. Right, so that's the end of the video. Please click like on this video if you enjoyed.